So hello everyone, I'm Máté Szén. As you can see, I'm a software development engineer at Vacuumlabs. I'm currently doing my studies as a software development engineer at the Budapest University of Technology and Economics. And I would like to invite you to a little dive into the Node.js event loop, what it does, why it matters, and what significance does it have in our everyday lives. So first of all, what is an event loop? Well, if you're a programmer, you might be thinking loops in general, like this, or even this, which is technically true. So it must be implemented in some shape or form. It is probably written like this, but today we will not be talking about this. We'll be talking about the actual implementation and about the phases the event loop has. So let's just think of it as a roller coaster that has many loops, starts somewhere and then ends somewhere. Before seeing what it actually looks like, let's just take a few words for Node.js and what it is. So in my book of definitions, Node.js is a JavaScript executor. I would use the word code runner, but it just feels a little bit unprofessional. So I would say it's a code, so it's an executor. Let's see how this long-awaited event loop looks like. Somewhat like this. So this is the general overview of the event loop. This is as close to as you can get as an official diagram, as it's created by one of the creators at Node.js. And we will dive into the initial stages that you can see later in this presentation. But first, let's have a look at why this matters from a financial perspective, the fin part of fintech, as this is a fintech forum. So, love it, hate it, JavaScript and Node.js are atop the currently most liked and most wanted technologies in web development. This is a survey done by Stack Overflow every year, and JavaScript is celebrating its 10th year atop this list. So I think it's absolutely relevant to talk about this. Node.js has a little bit of an unstable background because it was just this year that it was ordered top in the web technology section. So obviously, from another financial perspective, we can see that writing ineffective code will result in much more maintenance time and much more need for optimization, which will take up the client's budget and will take up the client's time. And I'm no statistician, but well, there's definitely something going on there. So as you can see, it will cost more in both money and in time, which is much to the client's dismay. So let's dive into the actual phases of the event loop. The first one you can see is actually the set timeout, and there's the entry point, which is not part of the event loop, is the user's code. Well, I named it index.js here, but it can be anything that you provide to Node. So the synchronous code is executed, and then comes the event loop with its first stage on its single thread, which is well, it's the set timeout. So, well, I'm very sorry, this is an older version of a presentation, but let's continue. So the set timeout stage is actually the first one that gets executed. So as the sync code is processed, we get all our timers scheduled, and all the pending timers are run at the first stage. Do note that yellow box JS that every stage has in between. It will be relevant in a future slide. Then comes the I/O, which we will talk about briefly at what it does and what the underlying code is. Then comes the set immediate callbacks, which is a somewhat misleading code because it would imply that it's executed immediately, but as you can see, it's just the third stage of the event loop. And at last, we have all the close events that are firing after everything is done. So the common misconception is that this is actually a queue. This is not a queue. This is just a line of events that come right after each other. And the steps might have some queues that or queue-like structures that are involved. One would be the timeout queue, which is executed as it was enqueued. And the I/O in the second step is always asynchronous, provided by libuv, which I have mentioned we will take a look at quickly. And after close, if nothing is left, we take it to the last stage, which is process.exit. And if everything is fine, then we exit with the 0 exit code. Now here we have an overview of the phases. Some numbers might suggest that when it is executed. So I have done it intentionally that they're not in order. So first we have an fs open call, which is obviously an I/O. We have a set immediate, a set timeout, which is scheduled for a 0 time, so almost immediately. And then comes some synchronous code and some promises, which we'll talk about a bit later. So the output will look somewhat like this. As you can see, the stages are in order. So first timeouts, then I/O, then the immediate, and the last stage is the close callback, which you can see at around the 8th line from the top. So libuv, here's like an abstract representation of what libuv is, which is quite similar to the event loop that we were discussing earlier. Two of them can actually be equalized to the Node.js event loop, one of which is the depending callbacks, which would be the second stage of the event loop, and the last one is obviously the fourth. So this is not thread safe because it runs on a single thread. It doesn't need to be thread safe. And the I/O operations are, when possible, deferred to a kernel. For once, it's using epaw on Linux and event ports on Windows and KQ on Mac OS. And it falls back to thread pool if one of these are not available. Now here's a little overview of how libuv itself is structured. As you can see, the 3 different stages that I've mentioned previously. Now we get to a slide where we can see 3 new callbacks in the code. So as you can see, I wrote a little helper here to schedule in some next tick callbacks, which you would expect to execute at some point or stage in the event loop, which it does not. Because next tick is something called a micro task. It is executed after every stage in the event loop. It is executed after the first, the second, the third, and even the fourth, but I don't have one there. So as you can see, those are the ones that I have scheduled. After the set timeout finishes, or the set immediate, or the file read, it gets executed. So what are micro tasks exactly? Micro tasks are both process.nextTick callbacks and are both promise callbacks as well. So in the first example, you might have seen promises, which were signified as a level 0 execution because they are executed immediately, also even after the sync code runs. And as you can see, after every single stage, if you remember the small yellow JS boxes, you can see that every time they get executed at the first, the second, the third, and the fourth stage. And this overall outer circle is the initial event loop that we had a look at in the first couple slides. Now, what happens if we remove all synchronous code from this? So as you can see, I've only kept the next tick schedules and the callbacks. Now the order is somewhat updated, to say the least. As you can see, the first timeout is scheduled on the third position, which is out of order. Now why does this happen? Because actually 2 loops are running. At the first, of course, all sync code gets executed and well, it starts the event loop. But even though this set timeout would look like it would execute immediately, it does not, because it is not due, as in JavaScript's terms. It's too fast. As you can see, at T0, the self-reading is already executed, so the file is already open. So we're already in the second stage of the event loop. And when it finishes, another loop starts. And since we have nothing in terms of phase 2 and 3, only one, and the fourth, the last one, is executed. Now, it's a common question in JavaScript terminology to sync or to async. Now, generally, we were talking about callbacks and stuff. So obviously, it is more common to use async functions or to use promises and all. But this is not always possible. When it's not possible, it's usually somehow substituted with a callback or some other similar structure. So I would advise everyone to try to use asynchronous code as much as possible. Now, concluding all of this, as I already mentioned, use async whenever possible, and forget all of those fs.read file sync and all of those, because those block the single node thread that we have available, and nothing else can run alongside it. Also, don't write other long-running synchronous tasks, such as CPU-intensive ones, for example, generating secrets from the crypto node package, or streaming compression, for example, zlib or gzip. Also, IO-sensitive tasks block the event loop as well. DNS lookups, streaming, reading, writing big files and huge payloads. So in general, moving huge blocks of data at once. Also, avoid the use of process.nextTick. I'm not entirely sure that most of you even know that it existed. It's generally there to ensure that a task gets executed as fast as possible if there is a need for that. Now, here's a pro tip that I usually follow. What I do is I write a wrapping function around my promises, which catch all of the errors, as you can see. And it also, well, in this instance, it logs out the output, which we don't have. But what this would do is it would avoid any So it would avoid any promises that have uncaught rejections, which are an instant kill to the node process as of the latest version. So this is a very useful function that I tend to write, and it's very good for a set timeout callback, as it wraps the promise and it follows all the other conventions that we've just discussed about. Now concluding some of these common mistakes and pitfalls that users might come into contact with, this one is called the pyramid of doom, otherwise known as callback hell, which is well, it looks like this. So when you nest callbacks, it's often an anti-pattern. You should use promises instead, and then return, because promises auto-expand and you can chain the promises as long as you'd like. The other one is some other promise bad patterns. So for example, just calling a promise does not catch any errors. So unhandled rejections will appear. Also for set timeout callbacks, it's also an anti-pattern. Some of these already have built-in ESLint rules that you can turn on if you would like to sanitize your code against these. You can see this might look correct, the bottom one, but it is not, because it calls two promises in a chain, and the last promise in the chain does not have a then. Now, thank you very much for listening. If you have any questions, we have some free time, about 10 minutes. If you would like to ask them any questions, I will be here. And I've put on my email address or LinkedIn if you want to reach out personally. So thank you very much for listening.